Hi Mark. So yeah, first of all, the I'm looking at the forward momentum, and as this thing bounces, the ball should maintain a pretty constant speed from left to right. So let's open the graph editor over here. Um, oh, I see. We've got that. Um, it's weird because you've actually got it so it's speeding up as it goes from left to right. See how this curve keeps getting steeper? Where if anything, it should be the opposite, where it should, um, you know, gradually get slower with each bounce. Um, so I might just take these guys and hit W and then shift middle mouse drag down, control select that, make the next one a little shorter than the last. That's kind of a straight line, and then it can be a touch shorter to kind of slow down each time. Something like that. Let's see how that looks. And if you want it to move further across the screen, now that I've got like the shape that I want, I could take the whole thing, R for scale, and then go right over this one, and then shift middle mouse drag and kind of scale that out so it goes a little further. That didn't do much. Oh, I'm sorry, wrong way. I meant I should have scaled it up. So I undid that. Again, R for scale, shift, middle mouse, click and drag right on there, and then scale it up so it moves further. That first one seems a bit much. I'm just, whoops, don't want to scale. It's W for move. Let's move that down a bit. Okay. That first one still seems too far to me. Okay, that's looking better for the forward momentum to me. You could always have it, again, go farther by scaling that up, to be longer. Like, again, select all these. R for scale, put your mouse right over that dot, shift, middle mouse click, drag it up. Get it to go a bit further. You could also have the height decrease with each of these if you want. I mean, the other thing is you could make it perfectly straight as if it's not slowing down at all. But what it shouldn't do, like you had doing before, is speed up. And then take a look at the squashing and stretching. So what you want to do is make sure you're maintaining the volume of the sphere. It shouldn't look like it's getting larger, and right now, especially on that squash, that just looks like a much bigger sphere. I also might clean up the Y curve here so that right now they're going below 0, these guys. I see you did the additional contact frame, which is good, but it seems to be going through the ground, so let's change all those to 0. Oops, that screws up our our tangents. That's just too bad. So just shift middle mouse drag and just, why is it messing up the tangent? So annoying. I don't really want to have to redo those. I wish it was smart enough to not mess up the tangent, but it isn't. Oops. Oh. Yeah, so you'd have to then go back and... Oh, these aren't broken. That's interesting. Make sure you break the tangents like so, and then you can affect it, separately on either side. I'm just selecting them and then middle mouse drag to pull those up to get the kind of bounce shape. yeah, select, marquee select like that, and then middle mouse drag to pull it up, but they need to be broken first. Meaning you can affect the left and right side separately. Okay, let's check that out. So, and then look at this. So now it's not going through the ground, but look at that, how it looks like the ball is actually getting bigger. So, I mean, if you want to squash it that much horizontally, which I would say it's more exaggerated. What I would go is I would go a little less like that, and maybe then you have to go further down for however. So maybe something more like that. And you don't have a stretch going back up, so you can do what do you have here? So you can do the sort of the squash, and then it comes back up. You can do kind of the recovery thing before it. I'm just going to do one there before it stretches, but then pretty quickly you'll want this to be stretched. Something like that. And then I might I guess you do have a stretch in there, but it should already be stretched here. Then it goes to 0. Okay. That one's a little better. Why does it appear to be not touching the ground? Oh, I thought I moved these up already. Okay, maybe they were different from each other for some reason. Yeah, so it goes all at 0. Alright. I still think it's this, I've got it a little bit too, the X a little bit too extreme, like that curve. I might make that a little bit more linear. Maybe move that up a touch. So it's not quite so curved, it's a little more straight. And then it won't slow down as much. Yeah, better. Alright, anyway, so there's a few things you can fix on that one. Here's the realistic bounce. And it has this thing where it comes down and it seems to kind of slow down and then accelerate. So let's take a look at the graph editor again. And take a look at this Y translate curve, and you really want to get a little bit more of that bounce shape in, and right now you're not getting a good bounce shape, so I'm not sure this is doing much for us. So I'm gonna make sure these are all at 0 exactly and break them all, break the tangents, and can do all of these at the same time. Can I? Yeah. Kind of move those all up. And then shift select. Move these guys out. Oops, we don't want that one. Sorry. Kind of get that more of that bounce shape. And I might move this W, shift middle mouse drag just to get that curve, and then I guess if that height is right, we know we don't want to go too high with that. And I might lose this guy just to delete, oops, and then adjust this accordingly. Yeah. So I'm getting more of that nice bounce shape. Let's see how that translated into the motion. Better. I feel like it maybe lingers too long in the air on that last one. Oh, and you have it where I think you want the height to be maybe point. I'm not sure. Let's see. When it touches, you want it to be whatever that is, 0.082 about. 0.094. So let's I'm just going to click that, copy that, and go back into my graph editor, select these kind of contact frames along the bottom, and then paste that in here, enter. And so now it should be touching, more exactly along the bottom. Okay, and then go ahead and animate in the roll here. So there's actually a mathematical formula which will tell you. It's interesting you have these fractional keyframes here like that. See, it's not lying exactly on the frame. You might want to just double click, right mouse click, snap, and that'll put it exactly on those frame numbers. Yeah, the formula is, anyways, don't worry about the formula. Well, I don't know. It's hard to say if it'll make it easier or harder. But if you look at, okay, let's just take a look. If we want to do this mathematically, it'd be interesting. Anyway, so 5.558, copy that, and then it gets to let's just call that 8. So 8 minus 5.558. So that's the distance it covers. So the formula is like 360 divided by 2 times pi times the radius equals I think that yeah, and you take that constant and you multiply it by the distance. So the distance covers is 2.442. And let's just do memory plus there. And then so 2 times pi is about 3.14 times the radius of this thing. I think should be the scale here, 0.445 equals so yeah, that times, it'll be a miracle if I'm doing this right. So 6, whatever, call it 6.8 times oh yeah, so that's that can't be the rotation. Oh no, so now so I did it wrong. Let's try that again. So so it's 360 divided by that number I just came up with. So 2 times pi times the radius. So it's 360 divided by this number. I'll just call it 2.8 to give me an even number. 360 divided by 2.8. Okay, and then so then that times the distance we covered, which I just took the it's where it starts rolling and where it finishes rolling, and I put that in memory. So times memory recall equals, so it should rotate 314 degrees. So let's see if I'm right. It'd be amazing if I'm I think that's rotate Z, and let's keyframe that here, and I might let's get rid of the other rotate Z stuff in between, and what did I say, 314? Is that 4? No, so it would be minus 314 because this is the negative direction. So minus 314. That cannot be right. Oh, maybe it is. Let's see. No, it is not. Okay, so I've done something terribly, terribly wrong with my math. So let's just kind of do this the old-fashioned way, and I'll just rotate it a bunch more and see how that's looking. Better. Oh. The other thing is probably make this linear. So that it, is moving the same speed, and then I have auto keyframe on, so when I rotate it like that, it'll automatically keyframe it there. That's actually pretty good. I'm guessing my problem was with like the radius, because if this is 1, that's probably way less than 1. So I'm not sure why. Yeah, I think that's where I went wrong with that, with the math there. There's this measure tool. I'm making this overly complicated, I know. Sorry. Oh, that's weird. Why is it elongated like that? Probably maybe from the last squash or something. Oh, that's kind of weird. Is it like that the whole time? I think this just needs to be, I guess you didn't do any squash and stretch, so this whole thing, you can delete all these keyframes and just make them all that size. Or maybe you want to make the whole thing bigger. Yeah, I'm trying to use this measure tool to see exactly how big this is if we wanted to. Distance tool. Click point to measure distance from. Click point to measure distance to. But it's like it doesn't do the second one. Weird. Maybe if I, what I could do is just make a sort of a default cube and then scale that down, or default sphere or something. Just scale it down to match. So right now, that's the radius of this is exactly 1 grid unit. So that's where my math went wrong, which is that the radius was wrong. So let's call it 0.092 for the radius. So in that case, again, you can just eyeball it. It's frankly probably better to eyeball it, but I just thought this would be interesting to show. So 2 times pi times, what did I say the radius was there? Did I copy it? 0.092. We'll just copy that. Okay. So it's 2 times pi times, let's paste that in there, equals that. So it's 360 divided by, let's call it 0.58 just to make it easy. So 360 divided by, did I say 0.58? Is 620. So it's saying that's how much it should rotate. Let's see how much I actually did it. So starts out at minus 80, which is a little bit confusing. So let's have it start out at 0 instead. And just to get an even number there. And then what did we say? Dang it. Should have copied it. I did minus 808, but it wasn't like 600 something. Sorry, let's do it one more time. Yeah, so that's the radius, so times 2 times pi. Oh yeah, so plus 0.58, so 360 divided by 0.58 equals 620 times, what was the distance it covered again? I should be writing this stuff down. So 620, so it's 620 times the distance it covers. So it's moving about 1, 2, like a little over 2. So we can do that math. So 620.7 times whatever this is, this number, minus 8, okay. So let's just put that in memory, 620.7 so that's 8 minus that, okay. Just copying that. 8 minus this times memory recall equals, oh wow, 1500. Why do I keep closing that? 1515. So that's a lot more than I did. Minus 15. Let's see how that looks when we look at it close up. I kind of believe that actually. That looks about right to me. You know, it's hard to tell unless you didn't do fractional keyframes, but it looks like the math actually is indeed working. So I'll just write that down for you guys if anybody actually wants to do the math. 360 divided by 2 times pi times r, where r is the radius, and then that whole thing times the distance equals the rotation. But again, you can just eyeball it and you'll probably get away with it. But I just think that's interesting to know that you can do it mathematically. Okay, long boring lecture over.